Bismillahirrahmanirrahim. Assalamu alaikum. Dear student, today we discuss the topic Charles Law from chapter 5 Physical State of Matter. The behavior of gases towards pressure, volume, temperature, and amount of gases is governed by Charles' law. Pressure and amount of gases is constant in Charles' law, whereas temperature and volume is variable. This law was presented by Jacques Charles in 1787. The volume of given mass of a gas is directly proportional to the absolute temperature at constant pressure. Here, the volume of a gas is directly proportional to the temperature if pressure is kept constant. What is the absolute temperature? The absolute temperature means the temperature on the Kelvin scale. Each temperature on the absolute scale is 273 unit greater than the same temperature on the Celsius scale. K is equal to C plus 273 or K is equal to 0 plus 273 equal to 273. 273 is the temperature on a Kelvin scale known as absolute temperature. V is directly proportional to T. Proportionality is replaced by constant. In Charles' law, pressure is constant. So V is equal to Kc into T. Kc is Charles' law constant. It is the pressure. Kc multiplied with T. So V is equal to Kt. If we divide both side equation by T, we will get V divided by T is equal to Kc, which is defined as the ratio between the volume and absolute temperature of the given mass of a gas is constant at constant pressure. Boyle's Charles' law is also known as the law of volume, and it experimentally explains this law by behavior of gases. When the volume changed from V1 to V2 and temperature from T1 to T2, then Charles' law is represented as V1 divided by T1 is equal to V2 divided by T2. V1 initial volume, T1 initial temperature. When the temperature is increases, volume of the gas is increases, so V2 is the final volume and T2 is the final temperature. The ratio between volume and temperature of the given mass of a gas is constant at constant pressure. We can prove it by a simple experiment. If we fill a balloon with air and seal it, the balloon contains specific amount of air at constant pressure. If we put the balloon in refrigerator, the gas inside get cooled and balloon shrink, although the amount of pressure remain constant. We make the balloon very cold, it shrink and the volume of a balloon is decreases, show that the gases that are inside present in it are closer to each other due to decrease of a temperature, so the volume of a balloon is decreases. However, when we again warm the gases, the balloon expand and it shows the increase in volume by increase of temperature. Similarly, the following apparatus is used for the verification of a Charles' law. In this apparatus, the cylinder has a piston and it has a constant volume of a constant amount of a gas. The wall of the cylinder are heat insulator while the base of the cylinder is heat conductor. When the cylinder is heated at a constant pressure, the piston move upward and volume will increases. It is noted from various observations that the ratio between volume and absolute temperature remain constant and it verifies the Charles' law. If we plot a graph about volume versus temperature, the straight line is obtained which shows that volume is directly proportional to the absolute temperature. Question is arises, Either the volume of the gas becomes zero if the temperature is decreases. The answer is yes. The volume of a gas decreases to zero at a certain temperature, that is 0 degrees Celsius, or the absolute temperature, that is 273 Kelvin. As you see, when the temperature is increases and pressure remain constant, the volume of the gas is increases, and it show a straight curves of a volume versus temperature. So with the help of a Charles law, if we have a quantity of a volume and temperature, initial, final, then we can calculate any one of these four: initial volume, initial temperature, final temperature. For example, if 3 decimeter cube of air is heated from 300 Kelvin to 400 Kelvin, then 300 Kelvin is the initial temperature, 400 Kelvin is the final temperature. 3 decimeter cube of air is the initial volume of air, then at a constant pressure. When the volume of the gas, what will be the volume of the gas at higher temperature? So we have to find out the final volume, that is V2. V1 3 decimeter cube, T1 300 Kelvin, T2 400 Kelvin, and V2 we have to find out by using a Charles law. So V2 is equal to V1 T2 divided by T1. If we put the values in our formula, we get the 4 decimeter cube final volume. As both the temperature are in Kelvin scale, therefore we do not convert it into Kelvin. If the temperature are given in the Celsius scale, we can convert it into the Kelvin scale by adding 273 in it. Now dear student, there is quiz for you. Define Charles law. How can we prove it? By example, give examples, and solve problem number 1, 3 and 5 of your exercise that are according to Charles law. Thank you. Allah Hafiz.